Hi guys, welcome to this video. In this video we are going to talk about the greatest angle uh, set of problems in properties of triangle. So I identified basically few problems that were involving a simple and similar concept, which is the greatest angle, and I thought I'll do one quick video regarding this concept. So let's get started. So I have one triangle, and it might not be obvious to you, but this is definitely the longest or the greatest side. And I have been mentioned the sides of the triangle as A, B, and the third side is square root of A square plus B square plus AB. Now actually I was just mentioned this problem in the statement form, but I drew this graphically so you can visualize. But one thing to note here is that if you just read out the problem, it wouldn't be obvious to you that this is the greatest side. So we'll have to prove this to ourselves that this is indeed the greatest side. So let's prove to ourselves that this is definitely the greatest side. So if you just square both sides of so first of all let me write the inequality. So this is square root of A square plus B square plus AB. So we are initially assuming that this is indeed greater than A. So if this is greater than A, if I just square both sides, that would not change the inequality, right? So if I do that, I get A square plus B square plus AB is greater than A square. Now I just cancel A square, just same on both sides. I'm left with B square plus AB is greater than 0, which is true. What that means is that this is also true. So indeed this is greater than A, and we can argue the same thing about B. So basically that means that this is the greatest side. And why did we just want to figure out the greatest side? Well, because if you just think about this, if we have a greatest side, the angle which is opposite to the greatest side will be the greatest angle, right? Because just imagine that this was not the greatest side, this was any other side. Let's suppose that this was the smallest side, so the triangle would have been something like this. So if I just redraw this triangle, this is A and this is the smallest side, let's say C, and this is B. Now obviously, as you can see, since this is not the greatest side, the angle which it subtends, I guess this angle, it's not the greatest angle. So what that means is that if I want the greatest angle, I have to first figure out the greatest side, because that's the only side which will the angle opposite to the greatest side will only be the greatest angle. So in this case it seems like A is the greatest side. So I think, as you can visually see, the angle which A subtends is definitely bigger in size compared to this side, C. So so since A is the biggest side, the angle opposite to A is the greatest angle. And in this problem, since this is the greatest side, this angle, I'll call this capital C, is the greatest angle, and we have to figure out this angle. So we need to refer to our toolkit once again, and right now we have the law of sines, or the sine rule. We have the projection formula. We also have the formula relating the area of a triangle with the sine of one of the angles, and we also have the cosine rule. So we have a lot of options. So let's think about what we can apply. So since we are given with all the sides, it seems very tempting to use the sine rule. So if we just go with the sine rule, so sine of a upon a is equal to sine of b upon b, and then sine of c upon square root of a square plus b square plus ab, right? And this is equal to some constant, let's call this k. So as you can probably see, we would land nowhere from here because we want to figure out the greatest angle. In other words, we want to figure out c or sine c. So if I want to figure out sine c, I can use this equation, but I'm getting everything in terms of the unknowns, which is like a, b and k, which I don't want because I need a definite answer like 90 degrees, 120 degrees. So we cannot use the sine rule. Sine rule is only used to relate the sides of a triangle with the angles, and that's exactly what it is doing right here. It's relating the sides of a triangle with the angles, but we need a definite angle, like we need a particular value of c, not the value of c in terms of sides. So hopefully you understand that. So if you think about this, we can use the cosine rule as our next option from the toolkit, which seems very suitable under this scenario, because if you remember that let's figure out. So since we want to calculate c, I have to write the cosine rule for this side, which is opposite to c. So it's going to be c square is equal to a square plus b square minus 2ab cosine of the angle included between a and b, which is c. So by using this equation, so if I use this and c square, we are given that it is equal to a square plus b square plus ab. So if I just substitute the value of c square, I'll get this, and it should be immediately obvious to you that these two guys are the same, these two guys are the same, and what we are left with is AB is equal to minus 2AB cosine of C, and let's cancel AB. So one second, let me scroll down a little bit. So we are left with cosine of C is equal to minus 1/2. If you solve this equation, you are going to get that C is equal to 120 degrees. So you saw that we had both options. We could apply the sine rule because we were given with the sides, but since sine rule only relates sines of angles in terms of sides, we couldn't actually get a specific value of angle C. Instead, what we would have got is the angle C in terms of A, B and K, which we didn't want. So we applied the cosine rule instead, and once we did that, we got a definite value of C. So yeah, so that's it. Let's take one more problem. This is actually almost identical because this is a specific case of a more general problem that we just solved. So anyway, the problem is that we are given with the sides of our triangle. So let's say that this is a triangle, and it might look isosceles, but it's actually not isosceles. So this is 2, this is 3, and this is square root of 19. Obviously it is not drawn according to the actual scale, but just to give you a rough idea. So this is our triangle, and we have to figure out the greatest angle. So once again, the greatest angle is the angle which is directly opposite to the greatest side. So I'm pretty sure that it's obvious to you that square root of 19 is the greatest side. So this is indeed the greatest angle C, and we can again make use of cosine rule to figure out that. And in fact we just did that. If you just look at this above problem where we had a, b, and this third side which is square root of a square plus b square plus ab, this second problem is just a specific case of that problem in which a is equal to 2, b is equal to 3, and c is equal to square root of 19. So what that basically means is that the greatest angle in this case is also 120 degrees. So yeah, thanks for watching this video.